CIET NCERT presents audiobook Curiosity, Textbook of Science for Grade 7.
Page number 41, Chapter number 4, The World of Metals and Non-Metals. A QR code is provided at the right side of this page, which can be scanned to get access to other resources related to this chapter. Yashwant and Anandi live in a village in Rajasthan. Their school has assigned them a project to learn about craftspersons who work with metals. They decide to visit the local ironsmiths who practice this craft. Yashwant and Anandi request their grandfather to accompany them. Figure 4.1. Here, Figure 4.1 depicts ironsmith making various items. They are curious to learn how these ironsmiths make different items of daily use. They interact with an elderly craftsperson, Sudarshan uncle. Yashwant asks, "Which items do you generally make?" Sudarshan replies, "Generally, we make items of daily use, such as flat pans, tawas, buckets, baltis, tongs, chimtas, and farming tools like spades, favras, axes, kulhadis, trowels, khurpis, and rakes, jailies." Anandi asks, "What materials are they made of?" Page number 42. Sudarshan responds, "We use iron metal to make these items. We also use wood to prepare handles wherever required. Additionally, we use coal in our furnaces to heat the iron." Sudarshan is heating an iron block in the furnace. It has become red hot. He starts beating it hard with a hammer. Anandi is amazed and asks, "Why are you beating it?" Sudarshan replies, "I am beating it to shape it into an X." Anandi asks, "Wow, a piece of iron can be beaten into a flat shape. Can we do this with other metals as well?" You may also have many such questions. Let us explore what else we can do with metals. 4.1 Properties of Materials. 4.1.1 Malleability. Activity 4.1 Let us explore. Question: Conduct this activity under the supervision of your teacher or an adult. Point number 1. Collect some waste pieces of copper and aluminium, an iron nail, a piece of coal, a pea-sized lump of sulfur, gandhak, and a block of wood. Point number 2. Recall the chapter Materials Around Us in the Grade 6 Science textbook Curiosity and observe the appearances of the above items. Are they lustrous? Also, note whether they are hard or soft and record your observations in Table 4.1, which will be discussed later after this activity. Point number 3. Now place each of these items one by one on any hard surface and beat them with a hammer. Figure 4.2. Figure 4.2 Beating an iron nail with a hammer. At the left side of this page, a figure 4.2 is there, which depicts a hand holds an iron nail on a hard surface and beats it with the hammer to observe if it flattens or breaks. Point number 4. What do you think will happen? Do the objects become slightly flattened or do they break into pieces? Point number 5. Record your observations in Table 4.1. Page number 43. Table 4.1 Appearance, hardness and effect of hammering on different objects or materials. On this page, a table is provided which is divided into 6 rows and 5 columns. First column is serial number, Second, object or material. Appearance, lustrous or non-lustrous. Fourth, hard or soft. Fifth, effect of hammering, flattens or breaks into pieces. This table lists 6 materials such as piece of paper, piece of aluminium, iron nail, piece of coal, lump of sulfur, pea-sized, block of wood. Next column is the comparison about appearance, whether these materials are lustrous or non-lustrous. Next column is the comparison whether the material is hard or soft. Next column is effect of hammering, whether it flattens or breaks into pieces. Blank columns are provided for each material where students can record their observations in this table. Analyze table 4.1. Identify the objects that are lustrous in appearance and hard. You might have observed that objects made from copper, aluminium, and iron are lustrous in appearance and are hard. Luster given by metals is known as metallic luster. Materials like copper, aluminium, and iron are known as metals, whereas coal, sulfur, and wood are non-lustrous and not as hard as metals. Are all metals hard and solid? Not really. Some metals like sodium and or potassium are so soft that they can be cut with a knife. There is one metal, mercury, that is found in a liquid state at room temperature, which you might have seen in thermometers. Recall the chapter, Temperature and its Measurement, from the grade 6 science textbook Curiosity. Which objects did you find become flat on beating with a hammer? You must have observed that objects such as a piece of copper, an iron nail, and a piece of aluminium become flat when beaten, whereas other objects or materials behave differently. This property, by which materials can be beaten into thin sheets, is called malleability. Most metals possess this property. Can you give some examples of metal sheets? You might have seen thin silver foil on some sweets and aluminium foil used for wrapping food items. These are formed due to their malleability. Gold and silver are the most malleable metals. Page number 44. A piece of coal or a lump of sulfur does not show this behavior. They break into pieces and are said to be brittle. On the other hand, wood neither gets flattened into a sheet nor breaks into pieces. Therefore, wood is neither malleable nor brittle. Now there is a box, holistic lens. This is an important box which provided at this page. This box offers horizontal connections to a concept from multiple perspectives. This box reads, The impact of iron on the progress of civilization of India. In the grade 6 social science textbook, Exploring Society, India and Beyond, you learnt about the Harappans. They knew how to use metals like copper and gold. They used these metals to make various objects, from utensils to jewelry. However, you would hardly find any evidence of the Harappans using a very prominent metal iron, which you see a lot around you today. This is because it took a long time before iron was used in day-to-day activities. However, once the use of iron gained prominence in the times that followed, it contributed significantly to the progress of civilization in India. For instance, due to its strength, agricultural tools like ploughs made from iron were much superior to those used previously. What could be the potential reason? That is generally considered that copper was discovered earlier as compared to the iron. 4.1.2 Ductility. Where do you find the use of metal wires? You might have observed wires of metals like copper or aluminium in electrical fittings. Some ornaments like bangles, necklaces, earrings, etc. are also made from metal wires. Metal wires play important functions in a variety of stringed musical instruments such as veena, sitar, violin, and guitar. This property of materials by which they can be drawn into wires is called ductility. This property of ductility is mainly possessed by metals. At the bottom of this page, a picture of a girl is provided who is telling two interesting facts. Fact 1. Gold is so ductile that 1 gram of it can be drawn into a 2-kilometer long wire. Fact number 2. The ductile nature of metals enables for the creation of this tea strainer with metal wire. A pick of tea strainer is also provided here. Tea strainer is made with this metal wires. Page number 45. Have you ever seen wires made of coal or sulfur? Obviously not. We can say that coal and sulfur are not ductile. There is an interesting box, Dive Deeper. Dive Deeper box contains advanced concepts that lead to questions for in-depth exploration of a topic. This box reads, do you know that ropes made of steel, a mixture of metal, iron, and non-metal, carbon? Wires can support heavy loads. Therefore, they are used in suspension bridges and in cranes to lift heavy objects. A picture is also provided within this box which depicts a suspension bridge, a long bridge held by strong metal ropes and towers. 4.1.3 Sonority. Have you ever noticed the sound produced when a metal spoon or a metal plate or a metal coin is dropped on the floor? How is it different from the sound produced when a piece of coal or wood is dropped on the floor? Let us describe a picture given on this page. At the right hand side and bottom of this page, a picture of a visually impaired boy is provided along with the dialog box. He is saying, I use the difference in sound when my stick hits wood or metal to help find my way. Let us start an activity. Activity 4.2. Let us investigate. Caution message. Be careful while dropping the objects. Step 1. Take a few objects such as a metal spoon, a coin, a piece of coal, and a block of wood. Step 2. Drop them one by one from a certain height. Step 3. Do you notice any difference in the sound produced by these objects? Page number 46. You would observe that the metal spoon and the metal coin produce a ringing sound. Coal and wood, on the other hand, produce dull sounds. This property of metals that enables them to produce a ringing sound is called sonority. And metals are said to be sonorous in nature. On this page, a picture of a boy wearing ghungroos and standing in dancing form is provided. He is saying, oh, the ringing sound of my ghungroos is also due to the sonority of metals. A picture of girl thinking about the school bell is also given and saying, now I understand the ringing sound of the school bell is due to the sonority of metals. 4.1.4 Conduction of heat. Have you ever observed the vessels used for cooking in the kitchen? You might have noticed that the vessels used for heating are made of metals. Can you name some metals that are used for making cooking vessels? Do you know why these metals are used for this purpose? Let us find out. Activity 4.3. Let us investigate. Caution message. This activity must be performed under the supervision of your teacher or an adult. Be careful while handling hot water. At the left-hand side and bottom of this page, figure 4.3 is provided. Metal and wooden spoons immersed in hot water. Now, step 1 of this activity. Place a glass tumbler on a table. Step 2. Fill it with hot water. Step 3. Take a metal spoon and a wooden spoon of almost the same size and thickness. Step number 4. Immerse both the spoons simultaneously into the hot water as given in figure 4.3 and leave them undisturbed for a few minutes. Step number 5. Now carefully touch the upper end of each spoon. Page number 47. Some discussion points. Point number 1. Which of the spoons get hotter? Point number 2. What does this experiment tell us about heat transfer along the two spoons? You may have noticed that the metal spoon is hotter to touch than the wooden spoon, even though both spoons are immersed in the water of the same temperature and for the same time. This shows that the heat transfer through the metal spoon, making it hotter. In contrast, the wooden spoon transfers heat poorly. In such cases, the transfer of heat from one point to another of a material is called conduction, and materials that transfer heat are called conductors. Based on the observations, one can say that metals are good conductors of heat, whereas wood is a poor conductor of heat. Now, we can understand why mostly metal vessels are used for cooking and their handles are made with wood or other materials that do not conduct heat. You will learn more about this in the chapter Heat Transfer in Nature. 4.1.5 Conduction of Electricity. Have you ever seen an electrician using a screwdriver? What type of material is used for making its handle? You may have also noticed the electrician wearing rubber gloves and shoes while working. What can be the reason for this? Activity 4.4. Let us design and create. Design an electric circuit like the tester circuit in the chapter Electricity. Circuits and components. Repeat the same activity using the materials listed below and record your observations in table 4.2. Point number 1. You may collect a few objects such as a piece of aluminium foil, an iron nail, a lump of sulfur pea-sized, a copper wire, a piece of coal, a piece of dry wood, a stone, an eraser made of rubber, and a piece of nylon rope. Point number 2. Predict which of these could make the bulb of the tester glow and which could not. Page number 48. Table 4.2. Conduction of electricity by different objects or materials. At this page, a table is provided which is divided into 4 rows and 4 columns, titled as Column number 1, Serial number, 2, Object or material, 3, Observation bulb glows or does not glow, 4, Good conductor of electricity or poor conductor of electricity. This table lists object or material such as first, piece of aluminium foil, second, iron nail, third, lump of sulfur, pea-sized. Third column is observation, bulb glows or does not glow. Here, students may record their observations in the given blanks. 4. Column is good conductor of electricity or poor conductor of electricity. Here also, blank space are provided for the students to record their observations. You might have observed that objects made of aluminium, iron, and copper make the bulb glow, whereas sulfur, coal, wood, stone, eraser, and nylon rope could not make it glow. Do you observe any pattern in the glowing of bulbs when using different materials in Activity 4.4? It is observed that all the materials that make the bulb glow are metals. Materials that allow electricity to flow through them easily are called good conductors of electricity. In contrast, materials that prevent the bulb from glowing by not allowing electricity to pass through them are called poor conductors of electricity. So, now we can understand that the plastic covering on the screwdrivers and rubber gloves protect the electrician from electric shock because these materials are poor conductors of electricity. We learnt that metals are generally hard, lustrous, malleable, ductile, and good conductors of heat and electricity. Now, let us learn how metals behave in the presence of air and water. 4.2 Effect of air and water on metals. Iron. You would have often noticed that iron objects develop brown deposits when left in the open for a few days. In which conditions would an iron object develop brown deposits? First, when it comes into contact with dry air only. Second, when it comes into contact with water only. Third, when it comes into contact with both air and water. Page number 49. Figure 4.4 Glass bottles containing iron nails. This figure is given in 3 cases. Figure 4.4a, where an iron nail is suspended using a thread in a glass jar having some silica gel. Case 2, figure 4.4b, where iron nail is dipped in water with a layer of oil on the surface of water. Case 3, figure 4.4c, where iron nail is partially dipped in water in the glass jar. Now, Activity 4.5, let us experiment. Question message: be careful while handling iron nails. Step 1 of this activity is: take a few shining iron nails. If you are using old iron nails, make sure to remove brown deposits from their surface by scrubbing them with the help of a small piece of sandpaper. Step 2. Take 3 clean dry glass bottles or test tubes with tight-fitting caps or stoppers. Label them A, B and C. Step 3. Take 3 iron nails and tie each iron nail with a thread. Step 4. Place 1 iron nail and some silica gel in the glass bottle A and tighten the cap or stopper, which is given in figure 4.4a. Silica gel makes the air dry. It is the substance that is used in small pouches in some medicine bottles, water bottles, shoe boxes, etc. to keep them dry. Step number 5. Place 1 iron nail in the glass bottle B. Pour freshly boiled and cooled water to remove dissolved gases into it until the iron nail is completely dipped in it. Now pour some oil to form a layer over the surface of the water as given in figure 4.4b. The layer of oil on the surface of the water prevents the air from dissolving in the water. Cap the glass bottle tightly. Point number 6. Place 1 iron nail in the glass bottle C and pour some water so that the iron nail is partially dipped. Keep this glass bottle unstoppered. This allows the iron nail to come into contact with both water and air as given in figure 4.4c. Step number 7. Place all the glass bottles undisturbed at room temperature and observe the changes for 8 to 10 days. Step number 8. Record your observations in table 4.3. At the bottom of this page, table 4.3 is provided. Table 4.3 Formation of brown deposit on iron nails. This table is divided into 4 rows and 4 columns. Columns are as follows. glass bottle, conditions, which is further divided into presence of water, yes or no. Second, presence of air, yes or no. And the next column is observations. This table records observations of glass bottles A, B, and C for the conditions titled as presence of water. Students may record their observation as yes or no in these columns. Second, presence of air, yes or no. Now, the observation column is also provided where students may record their observations in the given blank spaces. Page number 50. What can you conclude from this experiment? It is observed in glass bottles A and B that the iron nails do not show any brown deposits. What does this observation indicate? This indicates that brown deposits or discoloration on the iron nails do not develop when the iron nail is kept in dry air alone, bottle A, and water alone as given in bottle B. However, in glass bottle C, the iron nail shows the presence of brown deposits. This indicates that the presence of both water and air is essential for these deposits to develop. Thus, moist air is responsible for the development of brown deposits on objects made of iron. This brown deposit is called rust. The process of formation of rust on objects made of iron is called rusting. Many other metals also exhibit discoloration when kept open in the atmosphere. Have you noticed the formation of a green coating on the surface of copper objects or a black coating on the surface of silver objects? Gradual deterioration of metal surfaces caused by air, water, or other substances is known as corrosion. Do you know that rusting of iron is a serious problem in our country? Every year, an enormous amount of money is spent to replace or repair iron structures damaged due to rusting. The rusting of iron can be prevented by several methods such as painting, oiling, greasing, and applying a protective layer of zinc metal or iron, galvanization. We will learn about this in higher grades. Now there is an interesting fact, fascinating facts. This box, titled as Fascinating Facts, highlighting a fun fact: the wonder of ancient Indian metallurgy. This box includes a picture of iron pillar which is situated in Delhi. The iron pillar of Delhi was made in the time of Chandragupta II more than 1600 years ago. It is about 8 meters high and weighs more than 6,000 kilograms. What is interesting about this iron pillar is that despite all these years of facing winds, rainfall, and intense weather, it has barely any rust. In other words, it has been made in a way that it resists rusting. This tells us about the skills that were developed in metal technology in India. Page number 51. 4.3 Effect of air and water on other metals. Before starting this activity, let us know more about figure 4.5, where magnesium ribbon is burning with a bright flame. Let's move to the activity 4.6. Let us investigate demonstration activity. The teacher may demonstrate this activity. There is a caution message for all. It is advisable for students to wear protective eyeglasses and keep safe distance. Step number 1. Take a magnesium ribbon about 3-4 centimeters long. Clean it by rubbing with a piece of sandpaper. Step number 2. Hold it with a pair of tongs. Ignite the other end using a spirit lamp or a candle, which is given in figure 4.5. Step number 3. Let the magnesium ribbon burn. Step number 4. What do you observe? Step number 5. You must have observed that magnesium ribbon burns with a dazzling white flame and changes into a white powder. Collect it on a watch glass. This powder is magnesium oxide. It is formed due to the reaction between magnesium and oxygen present in the air. Step number 6. Add a few drops of warm water to this white powder. Stir it well and check its nature. Step number 7. Recall the chapter exploring substances, acidic, basic and neutral. Find out whether the solution of magnesium oxide is acidic or basic or neutral in nature. You can use any acid-base indicator. Step number 8. What effect does this solution have on blue and red litmus papers? On the right-hand side and bottom of this page, figure 4.6 is provided. Testing the nature of magnesium oxide. This figure depicts the white ash of burnt magnesium ribbon is collected on a watch glass. Red and blue litmus paper are dipped into its solution with water. Red litmus turns blue while blue remains the same. You would observe that it changes the color of red litmus paper to blue as given in figure 4.6. Hence, it is basic in nature. Generally, oxides of metals are basic in nature. We will discuss this burning of magnesium ribbon further in the chapter Changes Around Us, Physical and Chemical. Page number 52. Do you know that sodium is a metal which is stored in kerosene because it reacts vigorously with oxygen and water? A lot of heat is generated in the reaction. Storing sodium in kerosene prevents its exposure to moisture and air. Can you predict the nature of its oxide? Let us now discuss some substances that do not behave like metals. 4.4. Substances that behave differently from metals in air and water. Activity 4.7. Let us experiment. Demonstration activity. The teacher may demonstrate this activity. There is a caution message for all. This activity must be performed in a fume hood or well-ventilated area. Burning sulfur produces gases which can be harmful if inhaled. Before starting the stepwise activity, let us describe the figure 4.7 which is provided at the left side of this page. Figure 4.7a. Deflagrating spoon. It is a long-handled metal spoon used in experiments. Figure 4.7b. Improvised deflagrating spoon. Figure 4.7c. Burning of sulfur, in which sulfur starts burning in a deflagrating spoon and it is capped in a covered glass jar. Let us go step by step. Step number 1. Take a small amount of powdered sulfur in a deflagrating spoon. It is a long-handled metal spoon used in experiments to safely heat and burn substances, which is given in figure 4.7a. If a deflagrating spoon is not available, you may take a metallic cap of any bottle, wrap a metallic wire around it, and give it the shape as given in figure 4.7b. Step number 2. Heat it on a flame and as soon as the sulfur starts burning, introduce the deflagrating spoon into a gas jar or glass tumbler, which is given in figure 4.7c. Cover the glass jar or glass tumbler with a lid to ensure that the gas produced does not escape. Step number 3. Remove the lid after 3-4 minutes and take out the deflagrating spoon. Add a small quantity of water into the gas jar. Quickly place the lid back and shake it so that the gas dissolves. Point number 4. Again, recall the chapter Exploring Substances, Acidic, Basic and Neutral. Using an acid-base indicator, check whether the solution obtained after the addition of water to the gas jar is acidic or basic or neutral. Step number 5. What do you observe? Page number 53. You would observe that it is acidic in nature, as given in figure 4.7d. Figure 4.7d is provided on the right hand side of this page, which is depicting the testing of solution with litmus papers, where the red and blue litmus paper are dipped into the solution on a watch glass. On burning sulfur in air, oxygen, sulfur dioxide gas is formed. On dissolving sulfur dioxide gas in water, sulfurous acid is formed. Does sulfur behave in water the same way metals do? Activity 4.8. Let us explore. Point number 1. Take some sulfur powder in a glass tumbler. Point number 2. Add a small amount of water to it. Point number 3. What do you observe? You may have noticed that there is no reaction when sulfur is placed in water. Substances like sulfur and phosphorus behave differently with air and water than metals. Phosphorus is stored in water as it catches fire when exposed to atmospheric air. These substances are usually soft and dull in appearance. They are neither malleable nor ductile, and they are not sonorous. They are also poor conductors of heat and electricity. These are called nonmetals. Their oxides are acidic in nature. Some other nonmetals are oxygen, hydrogen, nitrogen, carbon, etc. These must not be confused with materials such as plastic, glass, wood, rubber, and paper. These materials are not classified as metals or nonmetals because they are not elements. There is an interesting fact. Dive deeper box is provided on this page. Metals and nonmetals are subcategories of substances called elements. An element is a substance that cannot be broken down into simpler substances. Presently, 118 elements are known. These elements are the basic building blocks of all matter. Some are naturally occurring, while others are artificially made in the laboratory and do not exist in nature. You will study more about elements in higher grades. Page number 54. 4.5. Are nonmetals essential in everyday life? You often observe many metals in your day-to-day lives because of their distinct properties, such as their lustrous nature, heat and electrical conductivity, and high strength. However, this should not give an impression in your mind that nonmetals are not important in our lives. We breathe in oxygen, which is a nonmetal, and without it, we would not be able to survive. Can you think of any other uses of oxygen? Carbon is essential in everyday life because it is the building block of all life forms. It is a key component of proteins, fats, and carbohydrates, which are necessary for growth and energy. Nitrogen is used in the manufacturing of fertilizers and other chemicals. It is an essential nutrient for the growth of plants. Chlorine is a nonmetal commonly used in water purification. A solution of iodine, a nonmetal, is applied on wounds as an antiseptic. In the middle of this page, an interesting box is provided named as Science and Society, which links the real-life applications showing how science has contributed to societal development. This box reads, do you know that many metals and their alloys, mixtures of two or more metals or a metal and a non-metal, are important for daily use as utensils and tools? These are also important for modern technologies and essential in almost every industry. Some special metals are also used in atomic energy, such as zirconium, aerospace, titanium, etc. In India, many metals, especially iron and aluminium, are recycled to minimize waste and contribute to sustainability. Now let us summarize this chapter into some points. In a nutshell, point number 1, metals and non-metals are differentiated based on their properties. Point number 2. Generally, metals are lustrous, whereas most non-metals are non-lustrous. Point number 3. Metals are generally malleable and ductile, while non-metals do not have these properties. Point number 4. Metals are good conductors of heat and electricity, but non-metals are generally poor conductors. Point number 5. Metals react with oxygen to produce metal oxides, which are basic in nature. Point number 6. Non-metals react with oxygen to produce oxides, which are acidic in nature. Point number 7. Generally, non-metals do not react with water. Point number 8. Metal objects get damaged when exposed to moist air, and the process is known as corrosion. Point number 9. Metals and non-metals have wide applications in everyday life. Page number 55. Let us enhance our learning. Before starting the exercise, on the right-hand side of this page, an illustration of a girl is provided, encouraging us to participate in this section. The girl is sitting confidently on a block with a question mark. She is climbing a rope, each step shaped like a stone, and has a question word on it. Words like what if, why, when, where, what could, how long, can it, whose, what will happen, what should, why not, what else. This picture reminds us to keep asking questions to learn better. The girl is holding a word block named as inquiry on her right-hand side. Let us start doing this exercise. Question number 1. Which metal is commonly used to make food packaging materials as it is cheaper and its thin sheets can be folded easily into any shape? Option 1, aluminium. Option 2, copper. Option 3, iron. Option 4, gold. Question number 2. Which of the following metal catches fire when it comes in contact with water? Option 1, copper. Option 2, aluminium. Option 3, zinc. Option 4, sodium. Question number 3. State with reason or reasons whether the following statements are true or false. First, aluminium and copper are examples of known metals used for making utensils and statues. True or false? Second, metals form oxides when combined with oxygen, the solution of which turns blue litmus paper to red. True or false? Third, oxygen is a non-metal essential for respiration. True or false? Fourth, copper vessels are used for boiling water because they are good conductors of electricity. Question number 4. Why are only a few metals suitable for making jewelry? Question number 5. Match the uses of metals and non-metals given in column first with the jumbled names of metals and non-metals given in column second. Column first, used in electrical wiring. Second, most malleable and ductile. Third, living organisms cannot survive without it. Fourth, plants grow healthy when fertilizers containing it are added to the soil. Fifth, used in water purification. Column second. A, ENX. Column second, jumbled names of metals and non-metals are given in this column. A, ENX, YGO. B, NECOHIRL. C, PEPORC. D, TENGOINR. E, OGDL. Students need to match column 1 and column 2. Question number 6. What happens when oxygen reacts with magnesium and sulfur? What are the main differences in the nature of products formed. Page number 56. Before coming to the question number 7, let us describe a picture which is provided at the left side of this page. An illustration is given where a smiling boy is standing on the lowest step of a rope ladder. Each step above him has a special word written on it. The bottom step says curiosity, next step says exploration, above that is inquiry, and then discovery. And at the top, the final step says innovation. This picture shows how our curiosity can lead us to. This picture reflects how our curiosity can lead us step by step to new ideas and inventions, just like climbing a ladder of learning. Question number 7. Complete the following flow chart. In this question, an activity is represented in the form of a flow chart. It starts with a question mark box. We can assume it as a metal or a non-metal. This metal or non-metal is heated in the presence of air. After heating the metal, ash is formed. Now, water is added to ash, forming a solution. In the next step, the solution is tested using 2 litmus solutions. Further, its reaction for both the cases is given in the next step. Case 1. Change in red litmus solution. It turns it blue. Case 2. Change in blue litmus solution. Now, a blank space is provided for the students to write their observations. Now, at the left-hand side of the page, there is another illustration given. Question number 8. You are provided with the given materials. Discuss which material would be your choice to make a pan that is most suitable for boiling water and why. The materials are given as iron, copper, sulfur, coal, plastic, wood, cardboard. Question number 9. You are provided with 3 iron nails, each dipped in oil, water, and vinegar. Which iron nail will not rust and why? Question number 10. How do the different properties of metals and non-metals determine their uses in everyday life? Question number 11. One of the methods of protecting iron from getting rusted is to put a thin coating of zinc metal over it. Since sulfur does not react with water, can it be used for this purpose? Justify your answer. Question number 12. An ironsmith heats iron before making tools. Why is heating necessary in this process? Now, before coming to the next section, there is another illustration given on the left-hand side of this page, where a zigzag rope chart is provided depicting all the areas like history, art, geography, society, technology, economy are integrated. Let us do some integrated exploratory projects in the next section. Exploratory projects. First, Dhokra, Bidriware, Pembharti, and Kamrupi are some of India's famous metal art styles. Find out the states where these artworks are made. Also, make a collage of their photographs. Second, on a map of India, mark the states where iron, gold, aluminium, and other metals are found. Third, explore the metals and non-metals found in smartphones and find out how they help the phone work properly. Fourth, organize a classroom debate on whether the use of metals for comfort and luxury should be increased or decreased. Now, this chapter ends here.
Curiosity. You were just listening to this audiobook, Textbook of Science for Grade 7. Narration: Harsh Priya. Sound recordists: Ekant Vashisht. Production assistant: Surendra Kumar. Directed and produced by Vimalesh Chaudhary. This audiobook is brought to you by CIET NCERT, New Delhi, India.